everyone. Trust your day is good. Today we are moving to the part 3 of the what of our course and our topic, our course MTH102 and the topic limit. So this is the third time we are meeting on the topic, and today we are looking into how to simplify limit using rationalization. And I believe that we are all familiar with this reaction, like conjugate or something. How to if you are taught sword in your secondary school, you should be able to understand. Okay, now before I proceed, I would like to give you some tips that you have to note when solving limits. Okay, like assuming we have an indeterminate form, like indeterminate form. When can you say that limit is an indeterminate form? Is, let's say we have okay, let's say we have one, okay, let's say we have 0 over 0. This one is indeterminate. We don't want it. Do you understand? If you get this in your, when you are solving, especially when you use direct substitution, it means that it is an indeterminate. So it means you have to use another method. Let's say we have infinity over infinity. This one is also what? Indeterminate. Do you understand? Let's say we have 0 multiplied by infinity, indeterminate. Okay, let's say we have infinity minus infinity. That one also is indeterminate. Let's say we have 1 raised to power infinity, indeterminate. 0 raised to power 0. All this one are what? Indeterminate. Do you understand? And let's say we also have infinity over 0. So you have to know, if you have all this, it means that you have to use another method to solve that limit. And all this one, it says that the limit, if you get this, if you use direct substitution and you get it, or you use any other method and you get this, it means it is in what? Indeterminate form. I hope you get. So now another one that I want to talk about is okay, let's say we have something like limit as s tends to infinity of 1 over x. So the limit as s tends to infinity of 1 over x, we always give you what? 0. And let's say we have the limit as s tends to what? 0 of 1 over x, and that one will give us infinity. You understand? Let's say we also have limit as s tends to infinity of 1 over x raised to power n, and of 1 over, it means it is also what? 0, provided that if n is greater than what? 0. So if n is greater than 0, then you can say that this limit, the limit as s tends to infinity of 1 over x raised to power n, provided that n is greater than 0, is equal to what? 0. Do you understand? We still have another one. Let's say the limit as s tends to infinity of any constant, which is k, over x, and that one will also give us what? 0 for any constant. It can be 6, it can be 1000, provided that it is divided by x and your x is tending to what? Infinity, for any what? Constant. Okay, so that's what I want to tell you. So make sure that you familiarize yourself with all these concepts as we are going to be using them when we are solving questions. Okay, now let's proceed with our examples. Okay, don't forget to subscribe, like, follow, and comment and share to your fellow friends. There are several videos on my channel that you can watch if you have any problem or you get stuck in any of your what limit questions. So this part 3, go into the channel to watch part 1 and 2 for better understanding of this one, as each one is a prerequisite of what? Of each other. Okay, now let's proceed, okay, with our examples. Okay, I'm coming. Now this is our first question. The limit as s tends to -1 of this function, they ask us to simplify, and I already told you that the limit is not that it is at the what exact point of that value. No, it is as s approaching the value, that is s approaching -1. It may not be the exact value of that point. Do you understand? Okay, as s approaches what? -1, tends towards -1. Okay, now rationalization method. Okay, you should remember that for you to rationalize let's say we have something like let's say we have x minus root 2, and you asked over 2. You asked to rationalize this. You have to multiply it by the conjugate. Multiply both the what numerator and the denominator by the conjugate. And what do you understand by the conjugate? It means that multiply it by the what positive. Change the sign of that what root, that is x plus root 2, multiply by x plus 2 over x plus root 2. Multiply both the numerator and denominator by the conjugate of the what of the function. Okay, now here too, by rationalizing, you multiply it by the conjugate. And what is the conjugate of this one? Root x plus 2 plus 1. So you have that the limit, right, as x tends towards -1 of root x plus 2 minus 1, everything over what x plus 1, multiply by the conjugate for both the numerator and denominator, plus 1 over root x plus 2 plus 1. Now you still need another knowledge to solve this one too, because you can see that this one, it looks like different of 2 square. You have the same thing here, you have the same thing, this one is positive and this one is negative. And if you remember that a square minus b square is equal to what? A plus b, a minus b, right? So we have a plus b, which is this, a minus b, which is this. So it means that this one and this one all square minus what? 1 square. So you have that the limit as x tends to what? -1 of what? Root x plus 2 all squared minus what? 1 squared, right? Everything divided by x plus 1 root x plus 2 plus, okay, the root stays here, plus what? 1. Do you understand? So you can simplify this one by saying that the limit as x tends to what? -1, this one square will give you x plus 2 minus 1 over x plus 1 multiplied by the square root of x plus 2 plus 1. Okay, you can say that the limit as x tends to what? -1 of what? X plus 1 over x plus 1 square root of x plus 2 plus 1, right? So this one can cancel out, and you will have x limit as x tends towards -1 of 1 over square root of x plus 2 plus 1. So you can what? Use direct substitution now, because if you go and check this place, let's say we use direct substitution to solve this type of what? Using direct substitution, you will get what? Substitute -1 here, you get 1, which is 1 minus 1 over 1 minus 1, and that's 0 over 0. And I already say that whenever you have 0 over 0, it is what? Indeterminate. You have to find methods to solve it without using direct substitution, and by that you are using rationalization for this one. So that's why we have something like this. And here you can use direct substitution, which will be equal to what? 1 over what? Square root of what? -1 plus 2 plus 1. That one is what? 1 over 1 plus 1, which is equal to what? 1 over 2. So that's how to solve question 1. Okay, I believe you understand. So what do you have to do whenever you have square root plus any value? You just have to rationalize by multiply both the what? Numerator and the denominator by the conjugate of the function. And when you multiply it, so you will have both on the left hand side. And after multiplying it, maybe you can have a what? Method of completing the square. You will surely have it because you are rationalizing. So use your method of completing the square to simplify this one, and without using the bracket. You can still open the bracket if you wish, but you still get the same thing as x plus 2 minus 1. Okay, now let's move on to the what? To the second one now. So this is our second question. Some of you will be wondering that how are we going to do this one, since the what? Square root is at the what? Denominator. You still follow the same procedure. It doesn't matter if the square root or what you are rationalizing is at the bottom or at the numerator. Do you understand? So you just have to rationalize whenever you see square root and like an integer like this. Okay, now let's solve this one too. Multiply by the conjugate of the function, conjugate of this denominator, which is by what? Changing the sign, and multiply it through the what? Numerator and the denominator. You have that limit as x tends to 1 of x minus 1, right, over square root of x raised to power 3 plus 3 minus 2 multiply by square root of x raised to power 3 plus 3 plus 2 over x raised to power 3 plus 3 plus 2. Do you understand now? So you can now multiply by saying limit as x tends to what? 1 of x minus 1 square root of x raised to power 3 plus 3 plus 2 over, right? Method of completing like different of 2 square, you have that x raised to power 3 plus 3 all squared minus 2 all squared, because this one is positive and this one is negative. You have the same thing, so you can use method of completing the square. Now you can use different of 2 square. I'm so sorry. Okay, now let's continue from here. Now what do you have to do? Continue by saying limit as x tends to 1 of x minus 1 into square root of x raised to power 3 plus 3 plus 2, everything over this one will give you x raised to power 3 plus 3, right, minus what? 4, right? So you have limit as x tends to what? 1 of x minus 1 square root of x raised to power 3 plus 3 plus 2 over this one will give you x raised to power 3 minus 1. But x raised to power 3 can be factorized, right? And you remember that whenever you have a raised to power 3 minus b raised a raised to power 3 minus b raised to power 3, you will always get a minus b, right, into a squared plus ab plus b squared, right? Okay, now so this is your a and this is your b, so it means that this one can be represented by this by saying limit as x tends to 1 of x minus 1 square root of x raised to power 3 plus 3 plus 2, everything over x minus 1 x squared plus x plus 1. Do you understand what I'm saying? So this one can cancel. No, I'm sorry, this one won't cancel. This one cannot cancel this one. You have that the limit as x tends to 1 of square root of x raised to power 3 plus 3 plus 2 over x squared plus x plus 1. Do you understand? Now, okay, let's use direct substitution now, because I think it won't give us indeterminate. So substitute, you have that square root of 1 raised to power 3 plus 3 plus 2 over 1 squared plus 1 plus 1. So you have that this one is 4, square root of 4, that's 2 plus 2 over 1 plus 1 plus 1. So you have 3, which is what? 4 over 3. So that's how to solve this one too. Let's move on to the next part. So this is another question entirely. How are we going to solve this one? Okay, now let's continue. You can just say that this one is divided by 1. It's still the same thing as the original question. Okay, now multiply by the what? The numerator and the denominator by the conjugate, right? So you have that the limit as x tends to infinity of square root of what? X squared plus x plus 1, right, minus square root of x, everything over 1, multiply by square root of what? X squared plus x plus 1 plus square root of x, right, conjugate, divided by square root of x squared plus x plus 1 plus square root of x. So you have that the limit as x tends to what? Infinity. This one different of 2 square, you have that x squared plus x plus 1 minus x. Do you understand? X squared plus x plus 1, because this one all squared, minus this one all squared. So you have only x, divided by square root of x squared plus x plus 1 plus square root of x. So x can cancel x. Here you have the limit as x tends to what? Infinity of x squared plus 1, right, over square root of x squared plus x plus 1 plus square root of what? X. Okay, but this place, I just check it, so this place supposed to be negative x. I'm so sorry for the inconvenience. Negative x minus x, it won't cancel. So here we have that x squared minus what? 2x, this one's supposed to be negative 2 plus 1 You understand now? I'm so sorry. This one is negative. So you have that the limit as x tends towards infinity of okay, now you have to do a simple what manipulation here, and that's what limits are. You have to know how to manipulate that. If you bring this one out, what will it remain? If you represent x with x squared over x, will it give you x? You have to know how to manipulate algebraic something like that. Do you understand? Know how to manipulate, please. Here I can factorize my x, right? I can factorize my x squared, right? Okay, you can say that here you can factorize x squared out, x squared. So what will it remain? This one will remain 1 minus 2 over x, because you can say x cancel x. If you want to open the brackets now, you can say x squared multiplied by 2x, x squared multiplied by 2x, x will cancel x, so you will get your 2x back. I'm coming. You get your 2x back. Do you understand? And here 2 plus 1 over x squared, because if you want to open a bracket, if you want to open the bracket, you can say x cancel x, you have your 1 again, divided by, from this inner square root to factorize x squared, you still follow the same process. You have 1 minus 1 over x plus 1 over x squared, right? Because if you open the bracket again, you still get this same initial. So that's what we call manipulation, plus x squared into what? 1 over x, right? So now what will you do? This x can come out, which will turn to x, and this one to x. So you have that. So after doing that, you have x squared into 1 minus 2 over 8 plus 1 over x squared, everything over square root of what? Now the square root, you remember, we can say it is equal to a square root of x, where is x. So factorize x from both sides. Okay, x open bracket 1 minus 1 over x plus 1 over x squared. Okay, let me do the bracket like this, minus 1 over x, square root of 1 over x, square root. Don't forget the square root, because if you come and check, this is it. You can say x come out, because square root of x squared is x. So factorize that x out. You have the what? The square root of this one and the square root of this one over x. So you have that now x can cancel it remain 1x. So you have the limit as x tends to infinity of x into 1 minus 2 over x plus 1 over x squared, right? Everything divided by square root of 1 minus 1 over x plus 1 over x squared minus square root of 1 over what? X, right? Is plus, is positive. Now as x tends to infinity, let's do direct substitution. You have infinity multiplied by 1 minus 2 divided by infinity. I already told you at the beginning of the video, is equal to 0. Limit as x tends to infinity of this one too is 0. Everything over square root of this one is 0 is 0. Square root of 1 is 1 plus 1 divided by infinity is 0. As limit as x tends to infinity of 1 over x is what? Is 0. So plus 0 now. You understand? So you can now say it is equal to infinity over 1, which is what? Infinity. So the question, the limit as x tends to what? Infinity of this one is equal to what? 0. So you have to know how to manipulate, know how to factorize something out to get an initial something. Do you understand? So that's how limits are. Now let's move on to another question. Now let's check out this question. You have to follow the same thing, rationalize. So you have that the limit as x tends to 9 of square root of 1 plus square root of x minus 2 over x minus 9 multiplied by square root of 1 plus square root of x plus 2 multiplied by the conjugate plus 2. Okay, so now you can multiply. You have that the limit as x tends to 9 of this one, difference of 2 square, you have that 1 plus root x minus 4, right? Everything over x minus 9 into square root of what? 1 plus square root of x plus 2 plus 2. This 2 is out. Now, what do you have to do? You can simplify this one further by saying the limit as x tends to 9 of root x minus 3, right, over x minus 9 root 1 plus root x plus 2. Do you understand? Now, here you can say that, okay, this x minus 9 can be represented by something. That's why I say that you have to know manipulation. You have to think beyond the box. That, okay, what can I represent so that that up one will not be equal to 0, because if you substitute 9 to the numerator, you have 0. So you have to look for one thing that you can use this one to represent, that it will make this one to cancel and have 1 here. So, and by that you can say that the limit as x tends to 9 of root x minus 3, everything over, this one can be represented as root x all squared minus 3 squared, because you can say that root x all squared will give you x minus 3 squared will give you 9. So into root 1 plus root x plus 2. You understand? So difference of 2 squared, this one represents it, so you can expand it by saying root x minus 3, hope you are getting it, divided by root x minus 3 root x plus 3, difference of 2 squared, into root 1 plus root x plus 2. So this one can now cancel this one. Now you now have the limit as x tends to 9 of 1 over root x plus 3 root 1 plus root x plus 2. You understand? So you cannot do your direct substitution, in which you have 1 over, if you substitute 9 here, you have 3 plus 3, that's 6, into, if you substitute 9 here, you have 3, 1 plus 3, that's for square root of 4 is what? 2 plus 2. So you have 1 over 6 into 4, which is 1 over what? 24. So that's your final answer for the what? For this question. So the limit as x tends to 9 of the what they give us is equal to what? 1 over what? 24. Let's move on to the next one now. So this is another question for you. Here you have to rationalize. Don't let us waste our time. Of what? Root 1 plus 2x minus root 1 minus x, everything over x, multiply by root 1 plus 2x plus root 1 minus, okay, plus x, plus x over root 1 plus 2x plus root 1 plus x. Do you get what I'm saying now? Now you can multiply. Difference of 2 square, you have that limit as x tends to 0 of 1 plus 2x minus 1 plus x, don't forget this minus, divided by x into root 1 plus 2x plus root 1 plus x, right? So you have what? The limit as x tends to 0 of 1 plus 2x minus 1 plus x, everything over, okay, minus x, everything over x into square root of 1 plus 2x plus 1 plus x. I believe you should see something coming. This one is quite interesting. So you can now see that 1 minus 1 is 0, 2x minus x. So you have limit as x tends to 0 of x over x into square root of 1 plus 2x plus square root of 1 plus x, right? So you can now see that x cancels s. You have the limit as x tends to 0 of 1 over square root of 1 plus 2x plus square root of 1 plus what? X. Do you understand? So you can do your direct substitution, in which you have what? 1 over 2, because substituting 0 here, you only have 1, 0 here, 1 plus 1 is 2, so 1 over 2. That's that for that one. Let's move on to another one. Now let's check out this question too. Okay, you still have to rationalize. Do you understand? So the limit, nothing change, as x tends to 5 of 4 minus root 3x plus 1 over x squared minus 7x plus 10, multiply by 4 plus conjugate square root of 3x plus 1, right, over, I'm coming, that's correct, 4 plus, I want to check the question before, plus 3x plus 1. Now, do you understand? So we have that the limit as x tends to 5 of 16, right, minus 3x plus 1, everything over x squared minus 7x plus 10 into 4 plus root 3x plus 1. So you have that the limit as x tends to 5 of 16 minus 3x minus 1 over x squared minus 7x plus 10, okay, into 4 plus root 3x plus 1. I hope you are understanding these stuffs. So we have the limit as x tends to 5 of this one can give you 15 minus 3x, right, over x squared minus 7x plus 10 into 4 plus root 3x plus 1. If you do your direct substitution, let's say this one is 5, this one is 5, so you have 25 minus 35, that's 10, minus 10 plus 10, so you have an indeterminate. So it means that there is still something that you have to do, okay. Factorize this one. Let's say we factorize I'm coming 5, okay, let's say no 3, let's factorize 3, let's say minus 3, right, so you have x minus 5, right, over this one can also be factorized. Do you understand? So you have that this one is x minus 2, x minus 5 if you factorize, multiply by 4 plus root 3x plus 1. So this one can cancel this one, and now you have the limit as x tends to 5 of minus 3 over x minus 2 into 4 plus root 3x plus 1. Okay, now you can do your direct substitution by saying that you have minus 3 into, substitute 5 here, you have 5 minus 2, that's 3, into 4 plus, substitute 5 here, you have 15 plus 1, that's 16, square root of 16, that's 4. So you have that is equal to minus 3 into 3 of what, 8. So you can now say it's equal to what, minus what, this one can cancel this one, right? So we have what, minus 1 over what, 8, and that's the answer for this question. So let's move on to the last part of this part. Now here too you have to what, factorize, and you have to what, rationalize. So don't let us waste much time. As x tends to 0 of square root of what, 9 plus 4x minus square root of 9 minus 2x, everything over x squared, multiply by square root of, multiply it by the conjugate of this one, plus square root of 9 minus 2x over square root of 9 plus 4x plus square root of 9 minus 2x. Do you understand? Okay, now we have the limit as x tends towards 0. This one will give you 9 plus 4x, right, difference of 2 square minus 9 plus, I've expand the bracket because you see minus open brackets 9 minus 2x, but I have what, expand everything all together, divided by x squared into square root of 9 plus 4x plus square root of 9 minus 2x. So you add the limit as x tends towards 0 of 6x over x squared into square root of 9 plus 4x plus square root of 9 minus 2x. Okay, now you can see x cancel x, you have 1x here. Do you understand? And I don't think there is nothing you can do to this type of question again, because you can still see you want to what, multiply 2 by x is still the same thing as factorizing it out. And if you substitute 0, you have 0 here, 0, this one is 3 plus 3, right? So because 0 here will give you 9, 0 here 9, square root of 9 9, and that one is 3 3, so you have 3 plus 3, that's 6, multiply by 0 is 0, and 6 divided by 0, and that means is what, infinity, right? So it means that the limit does not what, exist. So not exist, the limit does not exist, does not exist. So That's the what conclusion for this what type of one, because we have 6 divided by 0 and that one is infinity, so it means it doesn't have limit, it means it converges. Okay, so that's how you can use what rationalization method to solve limit problems. So seeing you on the next part. Don't forget to subscribe, like, comment and share to your fellow friends. Have a nice day. Thanks for watching.